Carbohydrates are the polyhydroxyaldehydes and polyhydroxyketones. They are mainly divided into three groups, namely monosaccharides, disaccharides, polysaccharides. Examples for the monosaccharides are glucose, fructose. Examples for the disaccharides are maltose, lactose, sucrose. Examples for polysaccharides are starch, glycogen. Schematic analysis of carbohydrates. For this, to the unknown sample, conduct a Mollis test. It is positive for the carbohydrates. How we will conduct this Mollis test means, to the given sample add a Mollis reagent and to that add sulfuric acid from the walls of the test tube. It will give a violet color ring. This indicates the presence of the carbohydrates. After confirming the carbohydrates, conduct a solubility test. It will give positive for the monosaccharides and negative for the polysaccharides. How we will conduct this solubility test means, to the sample solution simply add a water. If it is soluble, it is a monosaccharide. If it is insoluble, it is a polysaccharide. If it is a polysaccharide, conduct a iodine test. To the test solution simply add a iodine solution. It will give blue color for the starch and wine red color for the glycogen. If it is a monosaccharide or disaccharide, conduct a Fehling's test and Bendick test. In Fehling's test, to the sample solution add Fehling's A and Fehling's B reagents and boiled on a water bath. It will give a brick red color precipitate, indicates the presence of reducing sugars. Similarly, in Bendick test also, to the test solution simply add a Bendick's reagent and boil on a water bath. It will give a brick red color, indicates the presence of reducing sugars. If it is negative, so this indicates the presence of non-reducing sugar, that is obviously sucrose. If it is a positive, this indicates the presence of reducing sugars. After that, conduct a Barfoot's test. In Barfoot's test, to the sample solution add a Barfoot's reagent and boil on a water bath. It will give a brick red color precipitation. If a Barfoot test is positive, this indicates the presence of monosaccharide. If it is negative, then it indicates the presence of disaccharides. So after confirming that it is a disaccharide, then we will go with a Wasserjohn test. So in this Wasserjohn test, to the 0.2 grams of sugar, add 0.4 grams of phenyl hydrazine hydrochloride and 0.6 grams of sodium acetate, 4 ml of water. Heat it on a water bath for 20 minutes and then cool and allow for crystallization. So after that, observe the crystals under microscope. If it gives a sunflower shaped crystals, this indicates the presence of maltose zone. If it gives a powder puff shaped crystals, this indicates the presence of lactose zone. If it gives a needle shaped crystals, this indicates the presence of glucose zone. For monosaccharides, conduct a Salmon's test. If it gives positive, this indicates the presence of fructose. So how we will conduct this Salmon's test means, to the sample solution add Salmon's reagent and boil on a water bath. It will give a red color precipitation, indicates the presence of ketosis. This is how we will analyze the carbohydrates.